All right. So we need to finish. So okay. So there was some problems with this part. Let me see if I can demonstrate it on camera. Okay, I guess I'll need some breakout wires. But uh, so we have a lot of work to do with just wiring and coding and all that stuff. But I need to get the mechanical design of this part right. And so basically, what we have here is so the design. Ooh, I'm still too loud, and I've tested it. When I'm too loud, it's the audio is terrible. So so this piece takes in two poles. So it's like this. Oh, it's kind of flipped on my screen. That's why I'm confused. Okay, and then this pen holder, which has a set screw in it, and then it has this dovetail. These holes are if I wanted to make it like an Etch-a-Sketch and mount it. But so we got the dimensions right where it falls in. Before it was a little bit, it sort of falls in. Sometimes it doesn't fall in, which is actually really annoying. I think most of the time it falls in. But the problem is if the center of mass of this thing is pushing this way, see, it's right now, it's not at the top, but if I jiggle it, it'll come down. So I don't know. It's one of those things where I'm a little bit surprised at, yeah, it's just not reliable. But the problem is, it's not a matter of, because this is going to be lying parallel to the board. I'm also thinking I might want to make this a little bit taller. I mean, it only needs like 5 mils of travel. Anyways, the problem is when we push up on this lever, you kind of need to push up on the middle. And I didn't really realize just how much of a selection that is. I don't know. We're going to do a test here, but when I push on this end, which is where I've designed it to go, it doesn't really work. I think, so what we're going to do is we're probably going to make, and we don't actually have that much room. And I don't know why there's a lip here. There's no reason for there to be a lip here. So the first thing we're going to do, I guess I'm going to need a screwdriver, and I'm going to need some breadboard breakout cables. And then we'll be able to use this Arduino as a test Arduino to see if we can just see if this lifting mechanism works, because I'm kind of thinking that we'll need to adjust this a few more iterations. But that's okay. I know we can get it to work. And then the other part that we're going to do today is we're going to add, so let's just hop back into CAD here. So let's go to the assembly. Let's see, do I have everything assembled already? Okay, yeah, and we even have this thing without the horn in there. And so what was nice about this, well, I guess not really. Maybe we could just add some more holes here. We could just add a couple more holes here and we'll reprint it. So the idea is that we're gonna build like an overhang, like a so this is the box right now. Looking at it, you know, from the front. Okay, the servo kind of goes here, and then there's the platform right here, and this is connected to the pen. And so we put a hole in the back there, and it goes like this. Okay, and I don't really care about the profile of it, but the main thing is that there's going to be a bolt here somehow. There's going to be a bolt here, and a nut here, and then there's going to be a spring. And this spring, since this is the platform connected to the pen, there'll be a force down. Ooh, what the heck? There'll be a force downward that'll press this thing in. The problem is, I'm guessing I need to make the whole thing quite a lot bigger. But I think we have a plan. So I'm going to add more mounting holes as my first little step, because I think what I want to do is, well, let's get the horn, the screwdriver, and test this setup, because I haven't even used a servo in so long that we just want to mount it. Oh yeah, and I got to get those parts. Okay, so I got some stuff to get. I don't have a key. Okay, so I've gotten a whole bunch of stuff, and I think the first thing that we need to do is we need to, getting distracted, but I do want to look at these springs. Okay, here we go. What's inside? 12 extension sizes. Extension type sizes. 8 compression type sizes. So we want compression, I think. Fuck, there's phthalate in here? Dude, come on. You can't build anything. Anyways, I'm thinking... maybe... Oh, I forgot to get the big bolts, too. We'll need the big bolts. Shoot. Okay. This might not be big enough, unfortunately. I think probably the most likely thing is we'll take one of these and we'll try to cut it. But I don't know if you're supposed to cut these. Because this is definitely bigger than 30 millimeters. I feel like we'll be able to find something that works. Okay. So let's just get this hooked up. Okay, I always forget on these. I always forget these. There we go. Okay, brown is... I don't know why this hasn't standardized more. Black to brown. White... red is power, so white, I guess. And then my brown, I guess, is signal. Okay, so this goes to 5 volts. Black goes to ground. Okay. White goes to 5 volts. Okay, and then brown goes to any of the digital pins. Okay, so pin 2. Okay, so let's just get this thing to turn. Oh yeah, I forgot. I need to get a USB hub. Shoot. Okay. Wait, I just kind of want to get this working. Let's just replace the mouse for right now. Guys, it's the new year. And basically what I said is that I'm ready to just start doing biology, and I really want to. I want to just start building out the lab and stuff like that. But I can't just ditch this project. I have to get this thing working and draw a pretty picture, and then... Oh, we're cooking up... Bro, when did you say that? 4 minutes ago? If you're still here, we're making the CNC pen plotter, and I'm just figuring out the mechanism that raises and lowers the pen. Okay, let's get cooking. Oh yeah, I don't have a mouse. The problem is if you disconnect the mouse, you instantly go for it. Okay, so we need to open up Arduino. And then everything should be working. We just got to get the COM port right. We just want to turn this thing. Oh, wow. There you go. But this is, wow, that was a long time ago, man. Alright, so what we want to do is go to Examples, Servo, Sweep. Just do this. This is going to take forever, though. The ESP32 is like 10 gigs of libraries or something crazy. I don't even know. Alright, so let's just, so pause, attach 9. Let's just make it 9. Okay. This should just work as long as we get this thing right. Okay. What's going on? Is it waiting for the freaking installation? Yeah. Why do I always do this? I always click the wrong thing. I always make dumbass decisions. So we gotta figure this out. I brought the calipers, but I gotta get the big nuts. And the USB hub. Might as well just go do that. Okay, so I got the big bolts, I got the USB hub, which will be nice, so let's just do this thing. Okay, so did this thing work at all? What happened? Can't open device. Okay, so that's clearly not it. What about this? There we go. Okay, cool. Wait, what's going on? What the hell is happening? What is happening? Do you hear that? Oh, you probably don't hear that. I mean, it's moving, but it's also not, like, doing it correctly. We don't have a horn, do we? Wait, I do. Hold on. God, that thing's annoying. We gotta stop this thing. Fucking stop. How do I stop it? Unplug it. That was weird, man. I've never had that happen before. I mean, I don't even know why I'm testing this, because clearly something's wrong. But whatever. We're going to put the horn on and just see if it actually... Because I don't think you guys got to see. They're both MG995, so they should meet some specification of what it means to be an MG995. Right, we're going to plug this thing back in. What the hell? What is going on? Wait, is it... Let's try to re-upload it. But God, this thing is annoying. Maybe this Arduino is kind of weird. That would be annoying. Hopefully it's just the cable. Alright, wait. So I guess I am going to... grab this other Arduino. Yeah, and I am going to write on the back of this. Well, this one has a marking. Okay, so let's just replace it. That was weird, man. What the hell? Hold on. Okay, so, well, the same thing is happening. So I definitely have something wrong with the wiring then. But I don't. God, dude, do you think it's just going to be something so simple? What the hell? What the actual hell? Okay, so what did we do? We tested a different board. We tested a different USB cable, or a different... We didn't test the new USB cable. No, but that is the cable that I've been using for the past whatever. So that cable is fine. What the hell? I'm using an Arduino Uno, and I have it hooked up by USB to my computer, and I'm running just the basic servo sweep sketch, and I checked that the wiring diagram is correct. But when I run it, it sort of works, but then it just continually, you hear the sound of the USB disconnect and reconnect sound, and it's just happening over and over again, so it's not fully sweeping. But I don't know, like what is causing this? I've tested a new Arduino Uno. I tested a new USB port, and I've used this USB cable in the past with no issue. And it successfully uploaded, but for some reason it just keeps disconnecting. Is it because it's still updating? No. Maybe I'll restart Arduino. Oh, bro, I forgot about that. Oh, yeah, dude, people are so dumb. You can't just wire it directly to 5 volts. It's the overcurrent protection. It's definitely overcurrent. Yeah, I forgot about that. So these wiring diagrams are so stupid. It's actually so lame that you can't. It's because they give all these toy ones where you can just do that. I wonder if we could use a toy one. I'm going to go grab one of those. I think I do have one of these real tiny ones. Because, actually, that's the only option. There's no way we're going to... Well, actually, no. Using the shield, it'll be fine because it does have... it does have a... I don't know if it has a regulator on it, though. See, the thing is with the shield has no regulator on it, so it's got to be getting 5 volts from this, which is kind of sus. But in the other videos, they did use something with a higher current. All right, so I think I'm going to get a small one of these, and then what is the correct way to do it? Right, I forgot how annoying this is. I don't need decoupling, but I do definitely need... Okay, I forgot about this whole thing. It's nice that I probably didn't fry my board, though. Hopefully. Okay, so what do I need to get? I need to get a small servo. And I need to get... I guess I'll try to look for a thing to power it to power these. But I am worried that I won't be able to use this and that the other one won't be strong enough. But there's only one way to find out. Okay. Okay, well, that's kind of unfortunate. But so I found this really small one. But the problem is I feel like it could lift it, but it's a different size. And I didn't really look too hard. Yeah. So I think the first thing we're going to do is we're just going to take this. And I'd prefer to actually have a breadboard for this stuff. Whatever, we don't need a breadboard. Who cares about breadboards? Okay, red to red, black to brown. Okay, we're going to plug this thing in. Okay, and then let's rerun this thing. Oh wait, it's not plugged in. Yeah. Well, that's no good. How is that wrong? For the love of God, I hope I didn't bust this thing. Honestly, that there's no way I busted it because it was working before it. Oh, is it a common ground issue? Oh, it's probably a common ground issue. All right, so what we're gonna do is we're gonna get a breadboard. Geez, these things always bubble to be so much bigger than they need to be. Okay, whatever. I'm gonna get a breadboard. We're gonna do a common ground and then see if that works. The thing is, I'm pretty sure that the video uses... I'm pretty sure that the video uses... this same type of servo. Because we got this, now we just need one more of these guys. For the love of God, I hope this works. There we go. Okay, cool. So fine. So we got it working. You can see this here. Can you see that? Anyways, so it's moving. So now the next step is, I guess we got to get the soldering iron out. I'm going to put this thing here. So, so we got to get the soldering iron out. And, alright, so let's unplug this. Okay, or actually, I guess this. Alright, so it's all dead. Where are those two little pieces? Alright, so I made these tiny little pieces that are going to go on here as a mounting bracket. It's kind of absurd if you think about it, but it's just the way the world is. And knowing my luck, I will run out of the bolt I need. Anyways, not to be so negative, but it's just always thing after thing, man. So, all right, but that's the next step. Is we just gotta mount this thing to this thing. So that means we need the threaded inserts, and we need a soldering iron. And I'm thinking maybe I'll just go inside to do the soldering. It's like it's not interesting, and we just need to get it done. So I'm going to take these pieces, and I'm going to use 4 threaded inserts to put it on here, and then I'm like pretty certain it won't work, but also I do want to, hold on, let's do this really quickly.
Hello. I swapped them for some Link. And you...
Oh, he is using a mini servo. Okay, so why don't we test this? And if not, I guess we got to order. I mean, I'm almost positive we have these. I just can't. 9-gram servo. Well, let's just try it. Why not? Right? What's the worst that could happen? Hopefully these things fit in here. Okay, so brown to this. They don't really fit in here. Fuck. Oh, wait, they do. They do. Okay. 5 volts to red. I think likely I am going to end up buying some, which means that it won't be done by today. Yeah, the mini servo. The mini servo is just because... So that means that we have like a torque... We now have like a pretty hard and fast torque requirement, because otherwise we just can't... Oh wait, but we don't want this. Okay, so let's just try to run it again. So plug this in. Okay, so it works. So maybe I can go in and try to find the horns. The thing is, now we have a new mount. Oh wait, actually, do you hear that? Oh, it's only if I hold it back. Yeah, that's interesting. There's a specific point that it uses too much current. It's when it changes direction. Damn, that's so fricked up, man. I don't know how they get it to work without overcurrent. We're using the same Arduino. Arduino Uno. Oh, you know what I think you need? Wait, hold on. I think what I need to do is, I just need to, get another 5 volts thing with a barrel on it. And then we could plug this in, and I think then, let me ask ChatGPT. If I have like a 5 volt, 2 amp, wall wart thing, and I plug it into my Arduino Uno, and try to drive the servo, even if the USB is still connected, it'll try to drive the servo with the power, right? With the like high current rail or something. The thing is, it's actually 5.4 volts, and so I don't know if having a 5.4 volts and a 5 volt thing is going to cause an issue. Oh, that's funny. Just put a diode in between. I don't really want to do that. I also don't want to use a regulator. Wait, but it also has like a I remember I had a really hard time finding. Oh, wait. Wait. I don't know what rev this is. Probably the first rev. Wi-Fi rev, mega rev. I think it's just this. Jesus. If the wall wart that I'm using with the barrel jack is too high, for current, not voltage. If the voltage is okay, it's at 12 volts, but the current is at like 2. I'm using an Arduino Uno. Is that going to be an issue, or will it just not consume that much? And why a higher current rating won't harm your Arduino. Okay, so good. So I think we have a route that this will work then. Because there's a regulator on board, right? Okay, so I guess we just need to test it. So we're going to get a 12 volt, 2 amp, or whatever amp. Because I think the amount of current that USB can provide is like in the milliamps range. It's like 200 milliamps or something. So it's like, it's not gonna be able to power this big boy. But I really want to use this big boy because otherwise we got to change the CAD and we got to change all this crap. And I mean, it would be nice to use this little guy, but I see a route where what we can do is we can put the shield on these things, but then also give it a so we'd still have to use 2 wall warts, which is kind of a pain. Would we? Actually, I don't know. I don't really know how that board works. Like, it would be kind of nice if it was an open source board and we could look at the traces. Okay, well, hold on. But it's only through the barrel because the barrel goes straight to a regulator, I'm guessing. Oh, wait. V in. Oh, they got a V in. But I think that that thing's 19 volts. That thing's big. So we need to find a 12 volt wall wart. Okay. I think I'm just going to go do that. It's going to be a pain in the ass. I always hate doing this. Okay. We could also... No, we can't do that. Does it have a current rating? All right, so we're gonna try that. Right. Well, that makes sense. The VN pin is connected directly to the input pin of the onboard voltage regulator on your. Since the VN is directly connected, it does not have reverse polarity protection. What does this mean? I should have asked specifically about... Yeah, there we go. Oh, the barrel jack has a diode. So you fry the regulator if you accidentally do the other way around. Okay, so I would prefer, but in general, I would prefer, well, actually, this is tough, right? Because, I don't know if the shield... I don't know why I made these cables so short, man. Okay. Hold on. Okay, let's see. God, I hate wires, dude. I hate wires so much. So what I want to know, to an unplugged one, is VN gets connected, but does that trace go anywhere? I don't believe so. But I wish I had more documentation on it, because what I'm worried about is if I connect both, because, man, this is the thing is, man, I wish this, dude, PCBs need to be open source, because I need to know if I connect both wall warts together, whether or not I'm going to fry this thing, because, oh, wait, okay, hold on, let's do this. V3.0. Protoneer O/1. Oh, awesome, man. Okay, this is exactly what I was looking for. So, okay, so wait, where's the power, okay, so that's the shield. Now we want to know where the power jack is. Okay, it's that. XV. Oops. This is version 2. Wait, can we get the thing for version 3? Dude, whoever did this is awesome, man. Who is this guy? That's freaking cool. Bertus. My man Bertus, dude. Doing some very, very awesome. So, So we don't really want the assembly instructions, but I do want to know about, that's so cool. That is so cool that they got the... Alright, so wait, let's go back to the schematic, because I think the schematic is all good. Let's just open this in a new tab. Man, those guys are awesome. That's really cool. And it's like obviously KiCad, which is super cool too. Actually, I wonder if we can get the CAD. That's the only instance of it. I wonder if you buy it from them, if they give you the, aw. When was this? Whoa! 2015 this thing was designed? Okay, so let's just figure out what we actually need to, because I'm being dumb. Alright, so we need to figure out this VIN pin. Oh, there you go. There you go. So VIN is not even touched. So that means... Wait. But what does that mean? That doesn't mean anything, because... Hold on. Okay, so let's figure out, where does XV go? XV. I wonder if we can find the actual KiCad. This is probably not the same one, right? Alright, so never mind. Alright, I don't really care. Okay, so XV. Where does XV go? Because I can't do a... This is definitely that terminal block. I know there's no regulator on this board, so I'm guessing that just, oh, V-mote. There you go. So the V-mote is the, okay, so that's it. Okay, so I'm so glad that I'm able to read a schematic diagram now. Like, after having done all that stuff, I can at least read this and be sure that I'm not going to burn myself. Because basically what I was checking is that I can use the 2 wall warts, and I can use basically the 5 volts rail here, and it's not going to mess with anything. So that means I can use a barrel jack with the base Arduino board. And I can use my other wall wart for powering the steppers. And I'm not going to, like, short them together, because that would definitely do something weird. I don't really know exactly what. Like, I'm not that skilled, but I do know that if I were to just take 2 wall warts, one at 12 volts and the other at 20 volts, and I were to just short them together with the same ground, I wonder what would happen. Let's find out. If I had 2 wall warts, one at 12 volts and the other at 20 volts, and then I plugged both of them into the same surge strip, but then I connected the ground together. I shorted them together, so I put ground to ground and then the voltage to the voltage. What would happen? Yeah, I guess this just comes down to understanding what's inside a wall wart. Anyways, yeah. So we just proved that that is not going to happen because. Oh, wait, actually, what is that? K6. What is that? Dude, this PCB is so cool. I got this thing for like $10, and I got the drivers with it. Okay. So now it's time to go find the wart. All right, good stuff. Found a 12-volt 3-amp guy. A jobby. But now we need to figure out if this will fit in here. Hell yeah. All right, cool. Okay, so let's test this thing out. Here's what we're going to do. I think we're safe, but we're going to plug this in here. Okay. And then we're going to plug this in here. So we have power. We have powered the Arduino Uno. But now we want to get the USB going. And then we want to see if... So we don't need this thing anymore. So this 5-volt 2-amp thing is not needed. We could technically do that, but I think the barrel is a better option because if we end up building a little enclosure for it, then we'll at least have like some sort of clean interface of how to connect and disconnect it. Okay, so now we want to take our cables out of the mini one, get this guy. So, wait, okay. Ground. 5 volts. And it goes into a regulator, right? And it's going to pull from there. So we're good. I feel pretty confident that this is going to work. So pin 9. Actually, I'm going to turn this off. I don't know why. Just in case I plug the wrong thing in. Okay, so we got the servo hooked up. All right, nothing's going to happen until we plug this in. Oh, wait, actually it's working. Oh, something stopped. Why is that? Did it take too much current? Now it's going. Okay, so what have we done? We have now found a way to power the servo solely from the board by giving it an external wall wart. Wait, let's unplug the USB now. Okay, and we've unplugged the USB, and we still have it, it's kind of glitchy, honestly. Like, why is it stopping? Why did it stop? It's supposed to run indefinitely. That makes no sense. It's not good. All right, let's just unplug this thing. But why would that even be the case? It was working too. Hold on. We upload. And we unplug this thing. And it runs, and then it stops. That doesn't make any sense to me. Where's the reset? Is that red button the reset? It's always bullshit. Okay, so currently what I've done is I have my Arduino Uno, and I found a 12 volt, 3 amp wall wart, and I've plugged that into the barrel jack. And so then, it should go into a regulator and be able to then provide the current I need so that I can plug my servo directly, my servo that's a MG995, which before, if you remember, was causing an issue where it kept disconnecting because the USB overvolting thing, or overcurrent thing, rather. Um, but now it should be getting its power from... It should be getting its power from the regulated 12 volts, which, should definitely have enough current. I think. I don't know. I don't know why. But anyways, the problem that's happening is that I have the signal pin plugged into pin 9 like normal. I have the power pin plugged into 5 volts for the servo. And then the ground pin to the ground for the servo. And then what happens is if I upload my sketch of the sweep, let's see, if I have the if I have the USB plugged in, right, if I have the USB plugged in and I upload the sketch and I just let sweep run, it runs for a little bit, like maybe a second, and then I guess overvolting or overcurrent kicks in and it disconnects the USB. But then if I unplug the USB and then click the reset pin, so now it's only powered by the 12 volts, 3 amps. It works for a little bit. And then it just kind of, it's like super, and then it just stops. And I don't know why it just stops. Oh. So I guess I need a small servo. That sucks, man. Dude, that's brutal. Wait, but wait, okay, wait. So let's go back to that how to power the Arduino thing. So instead of that, we want the 5-volt pin. So wait, what were the options? It says powering via this pin. That's what we want to try. But the thing is, yeah, I don't think that's a good option. Okay, so, damn, dude, I really thought I had it. That's so annoying. These Arduinos kind of suck. I wish they could take more current, man. Just to drive a servo, you can't even use it. Yeah, look at this. They're all See, look, some of these guys are like, yeah, look, why were we dealing with, yeah, this 150 milliamps? Damn it. So what is our step forward then? The step forward is just to get small. But even this one, let's see. Let's go on. Let me do my thing where I obviously fucking retarded. Okay. I want to know their maximum current draw. Dude, what? But this is a standard size, right? This is a standard thing. SG90. I could probably find more information. Oh, MG means Metal Gear. Okay. Fuck, dude. Come on, man. I hate servos. I gotta be honest. I hate servos. God, I hate servos so much. What if I just search for Arduino in here. Great. Bisphenol. Dude, we're all so screwed. Dude, why are all the Amazon questions always so stupid? Can someone suggest code to test the servo using either an Arduino Nano or Uno? I cannot get sweep to work even with the external 6-volt supply. These are not for you, Ard weirdo. Fuck this guy. Oh, someone go out and shoot this guy. What the hell? S51. Oh wait, here you go. Stall current. Oh wow, no, that's super high. What the heck? Damn it, dude, what the hell? I don't know why. Okay, hold on. Let's watch this video, though. I'm curious to know. Look, he's using. What does that say? TS90A. Wow, this is actually cool. What is Genius? That's cool. $9 SGs. I mean, should I just get them and just see if it works? What is this? This is Rev. Oh, R3. Dude, look at those chips on there. Look at that huge IC. Probably easier to assemble, I guess. Whole thing is so upsetting. I thought I had some too. Maybe I'm gonna go look really quick and see if I can find some of these, because I know that I saw them somewhere. I just can't remember where. Oh, wait. Oh, wait. Oh. I was reading the wrong column. No, so I should be able to pull 1 amp from this thing. Okay, so here's what I want to do. I want to test, because this mini one was giving us problems when... Oh, okay, so we might be fine. All right, so we're going to test this again. We're going to do the following. We're going to use the barrel jack. Okay, so brown to ground. Signal. 5 volts. All right, so I think that this will work now that I've read that, because realistically, we might run into the problem still. But if we can find a way to keep it's all about just making sure that the okay, so what we want to know and if I hold on to it, okay. Okay, cool. All right. So what we learned is that you can all right. What we learned is that you can drive a 9-gram servo kind of using the 5-volt output. But you definitely can't drive these MG995s. So we'll have to redo the CAD, but this is actually a little bit better. The thing is, I gotta find those horns. We kind of made a mess of this whole thing. Ay, ay, ay. Ay, ay, ay. All right, well, we learned something. Okay. All right, so I think we're good. I want to know if we can find... I'm sure people have catted this up. So we'll probably just get this. See, the problem with this is that it's way more... It's got... No, it's got 2. Okay. But if we search current on this... Great. All right, so I'm going to go look for them, because I swear we have a couple. Okay, so I can't find them. So what we're gonna do is we're gonna buy them. We're gonna CAD everything out.
Avoid using these boring phrases.
Okay, so let's just do that. Wait, is it the same? Is it the same? Who cares? I don't care about the Metal Gears, man. Someone said they couldn't get them to work, but I can't imagine that I'll have an issue. I mean, I'm getting the Metal Gear ones because the other one had a warning about bisphenol, and I'm fucking paranoid right now. So we're gonna do the. If it doesn't work, I'm gonna be pissed, but. Still doesn't specify anything about current, but I don't really care. Okay, so we're using the MG. What is it called? MG90S. Beautiful. Dude, GrabCAD actually sucks because you have to log in to get it. No, in any case, let's just get this thing. But we have the without. Okay. Ugh. Okay, so it's time to do some CAD work, I guess. So we can put all this away and just lock in on CAD. It's a little unfortunate, right? When are they coming? Tomorrow? Okay. All right. So we can unplug all of this because we really don't need any of this at all. Okay, so the wall warts. All right, so we're gonna do the design. We're gonna print everything so that tomorrow or the day after we can just finish up this project. I guess what we could test right now, actually, though, is we could test how GRBL servo works, because I've been meaning to do that too. Oh wait. So this guy used what is this?
Welcome to DIY.
I mean, we might as well just start off with get the config files. I mean, we're using quite literally everything identical except for we're flipping that wiring, I think. Oh no, I guess I have the same, but that's not correct, I think. He's got his logo over everything. Okay, wait, hold on. There we go. And this just goes to Z plus. That's so interesting that it's using Z plus instead of anything else at all. If we wait, oh shoot, I closed it. We need to go back to the wait, not that. Wait, where is it? Let's keep this open. Kind of what I want to know is I don't really know what that is. It's cool. This thing has a fuse. It's kind of cool. I didn't notice that. There's a fuse on this thing. I guess if it works, it works. So we got 5-volt and ground, so we can use that. Okay. All right, so the wiring of this thing makes sense. So maybe we want to do is sort that out, because that's the thing I'm most nervous about. CAD, I know at any time I can do. But this stuff is like a pretty big unknown. So, all right, I think that I'm going to do that. Okay, I'm going to take a walk around the block. And then we are going to lock in. And we are going to make this CNC shield power a servo. So we're going to use a GRBL servo. And we're just going to figure out, I think this is which one has the most stars? And which one's the newest? 10 years ago, 7 years ago. This one has 300 stars, and this one has 86 stars. But, I mean, we could just try both of them. I think I'm going to try the newer one first, kind of. Plus, because it has this diff. Do we get the compare? Here's the compare. Oh, wait. Right. Okay. Okay, so a bunch of stuff. And this is all in... Oh, CPU map. Okay. Limits. Okay, I don't know anything about that. That's weird. Jeez, what the heck? Bunch of hacks, but no documentation. Wait, we're using this one. Okay. Has nobody's opened an issue on this ever? Okay, that's a little sus. Cool. All right. And what's the other one? The other one still has no documentation either, right? pin D11. I don't, but this thing doesn't have a map that tells us. Well, maybe it is. Oh, okay. So someone came up with a convention that Z end stop. The thing is, this is broken out. Oh, is that all? Oh, those are all grounded. Okay. But then, wait, no. What are those? Where do those go to? So, okay, wait, hold on. So, what's N? Okay, whatever. It sounds like the Z minus N stop is where we put it to, given this picture and given, where is this? This picture. Oh, this one goes to Z plus. I'm guessing I should be able to change that pretty quickly. All right, so let's clone this. All right, let's just get this going. I think what I'm going to do is I'm going to disconnect everything. That way, I forgot these things are made kind of poorly. They're kind of tight. I don't really want to break these things. Because you don't really want to pull from the cable. You want to pull from the body, but I can't really get to the body. All right. We do need power. We actually technically don't need power. So let's just leave it unplugged. We can leave it like this. So okay, so we got our shield. We got the Uno. We're gonna put it on. Okay, snaps in. So then our thing here is we're gonna need we're gonna need to get some more breakout cables that are male to female, and then we'll do the wiring, and then we will plug the USB in, and we'll also plug the barrel jack in, and then we'll upload. Okay, all right, so we got a plan here. But I do wanna try to figure out from the diff if I can like figure out. There's no guide on this whatsoever. Okay, so this tells you to do this. This is probably defaulted though, right? All right, so let's just clone this thing. GRBL servo. Oh wait. Yeah. That's why it should be GH clone. Wait, can you do GH repo clone? Oh, nice. See, that's awesome. Oh wait. Fuck. See, that's the fucking... And hopefully this branch has been switched to the right branch. Eggbot. Perfect. See, that's... GH is such a good tool. All right. Look at that. Look at that. Look at that. Okay. So, config.h. Baud, blah, 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 blah. Okay, homing. We can just... I think what we want to do is just define this. Duplicate this, comment this out, and then we're going to do this. Okay. Dude, GRBL is such a sick piece of software, dude. CNC for the masses. Okay, okay, but what do I need to do? Because what I'm wondering is, okay, so...
That depends on what you mean by need to do. Here are some common things people need to do daily: hygiene, shower/bath, brush teeth, wash face, deodorant, eat, healthy meals, and snacks, sleep, 7 to 8 hours of quality sleep, stay active, exercise or movement, hydrate.
Oh my god, dude. Oh my god. Yeah, Gemini, thanks a lot. Thanks a lot, Gemini. That's my cue to turn off my phone. All right. Okay, what do I need to do? What the hell? Hey, where was that thing? What is happening? What is happening? Okay, the thing is, okay, wait, let's see if we can find a data sheet on the ES08A2. I don't know, it says analog on it, which I don't even know what that means. No downloads? Dude, look at this terrible website. Why is this more than a third of the screen? Okay, let's just try to upload it, right? Is that crazy of me? So we're gonna plug in this thing. We're gonna plug in the USB. Okay, then we're gonna get the cables. Okay. All right. The little servo that could, am I right? Okay, so this signal goes to Z plus or Z minus. I don't even know how we're gonna figure that out. Okay. Then this is black, and this is 5 volts. Okay. Wait, let's unplug this. Let's unplug this. 5 volts ground. Five volts. Okay, so the servo is technically hooked up, but I just don't know which pin to hook it up to. I guess we could just try different ones, but I don't know if that's gonna work. All right, so we need to go to this, and then we need to do this weird thing, right, where we like manage libraries. Wait, that's not right. Wait, is it? Or is it like in preferences? Where do I go to add? Oh, I know, no. You know what I need to do? I remember what I need to do. Okay, so let's go. What you need to do is you take this, you copy this to like documents, Arduino, libraries. Oh, shit. All right, so what we're going to do, rename this. Rename. Okay. Then we're going to go back. Great. Okay, so we should be good. So now, if we like close all of this crap, then we go to Arduino. Okay. Okay, so we're gonna plug. Well, let's just wait. We're gonna Oh, it actually moved. I don't know why it moved. All right, I'm gonna upload. Dude, the Arduino software just—it's like if an error occurs, why do you keep doing this? Whatever. We'll just wait for it to time out. Anyways, oh, I should actually I should check if that product listing for the okay, oh, nice. And it comes with the one horn. That's great. Okay, so we got the right thing. Okay. All right, so let's do it again. Okay. Nice. Nice, nice, nice. Okay, so what do we want to try to do? We want to try to control. So we need to do the M. So let's go to the documentation. It's C prezes. We need to start with set the max. Let's see what $30. What is $30? And then we want to do this. And then how do we tell it to go somewhere? I don't know. So how do we do M3S255? It doesn't say how you actually use this thing. No, let's watch the video. Part two.
Report list of this project are housed in this container, which is kept cool by a small fan. The addition of 2 ports makes it very easy to pack up or move your project elsewhere. If you haven't yet seen part 1 of this video series, which covers the 3D printing and assembly of the machine, then you can find the link to that video up here in the corner. I've also put one in the description below. Now, this video is going to be a little bit more wordier than mine usually are. This is because I'm going to endeavour to show you how to test your machine. What you'll need to do is upload Gerbil to our Arduino. Gerbil, which can be pronounced as Gerbil, Gerbil, Garble, or even GRBL, is some free open source software which is used to control CNC machines.
He talks so
ideal
slowly.
for our project. However, it is designed to control machines which have a spindle or laser attached to their heads. We will be using a servo in our machine to move our pen up and down, so we're going to run a modified version of this software. This is called MeGerbil. You can find a link to download this software and any of the other software that I talk about during this video in the description below. Download the Gerbil Me folder, unzip it, and then copy it into your Arduino's library folder. On a Mac, this is usually users/yourname/documents/Arduino/libraries. And on a Windows, it's usually some...
Alright, let's do that. Where's his? Okay. The problem is he messed with the thing, so I don't know. Dude, what is running? Why is my computer like hot? Whatever. I don't care. Okay, does he say how to...
like My Documents /Arduino/Libraries. Open the Arduino IDE, again, links to download this are in the description, and in the menu, go File, Examples, Gerbil Me, Gerbil Upload. Connect your Arduino to your computer using a USB cable. Select the Arduino Uno board type in the Tools menu, and the correct port for your Arduino, and upload the sketch. Once the upload is complete, you can open the serial monitor and set the baud rate to 115200. Sending $2 should return Gerbil's current settings. To begin with, we will upload a set of configuration settings for the design as I have built here and have shown you in the first video. We will use this to check that the motors work properly and that our limit switches are responding as they should as well. I have put a link down in the description to where you can get a copy of these configuration files. Copy and paste the settings line by line into the Arduino serial monitor, and they will automatically apply themselves to your Gerbil installation. You can verify this by sending the $$ again to see the current configuration, which should be Gerbil installation. You can verify this by sending the $$ again to see the current configuration, which should be different to what we saw earlier.
There's no $30 in this one.
As a quick side note, the configuration for Gerbil is saved to some non-volatile memory on board our Arduino. This means that it will be remembered when we power off our Arduino and power it back on later. So don't worry about trying to reload your configuration every time you switch your machine on again. Before we begin testing the hardware, gently and slowly manually move the CNC machine so that the head is roughly in the center of the expected working area. As we have some homing switches configured on our CNC machine, when we first switch it on, it will start up in an alarm state. This is because it cannot be sure at the moment where its head is in relation to the rest of the machine. To resolve this, we will trigger a homing sequence which will move both the X and Y axes to their very ends until they make contact with the limit switches. These two switches are located here and here. We will issue the homing command to our Arduino in a moment, and what we want to see happen is the axis to move all the way to the left and all the way to the bottom left corner of our drawing area until it engages those two contact switches. At this point, it will perform a small bounce on the two contact switches to improve its accuracy, and then we will read OK in the serial monitor. Be prepared to disconnect the power if your machine does anything other than this. If it does, recommend going back to the part 1 video and checking your work, paying attention to the electronic connections so far. You can also take a look at my website for some FAQs on this project's page to fix some of the most common faults you might come across. If it has worked just fine though, we'll move on to testing the servo's ability to move the pen up and down in its
There
slider.
we go.
To do this, issue the command m3s90 .
Well, something happened. It worked, but then it instantly did. Wait, can I just do it again? Okay, it's working. But it's definitely... How come his works, man?
followed by M5. The servo should pull on the timing belt and raise the slider when M3S90 is issued. This should have lifted the pen slider upwards very near to the end of its travel, and our servo should not be continually straining to try and pull it any further. If it is, refit the timing belt inside the 3D printed arm on our servo, giving it a little bit more slack.
Do you respond to comments or no? Yeah, he does. Kind of. Okay, wait, hold on. Let me just ask this. Okay, wait. All right. So I have a small mini servo, ES08A2 analog servo, but here's the thing. Okay, so I have my CNC shield hooked up to my Arduino Uno. I have the 12 volt 3 amp barrel connected to the Arduino Uno, and then I have the USB of the Arduino Uno connected to my laptop. Now, when I upload GRBL, everything seems to, and it's the modified GRBL that has support for the servo in the Z-axis to raise and lower my pen for my pen plotter. Now, the problem is that what's great is that it works. When I do the M3S0 and then an M3S100, it correctly moves the servo, which is great. But then I think I'm getting another overcurrent problem because it instantly disconnects the board. But the thing is, like, I've plugged in the wall wart to the board, but I guess it's still relying on the USB 5 volts, even though that is known to not be able to supply enough current to the servo. But the thing is, if I want to use GRBL for G-code, I'm going to need to use the USB to the computer. So I just don't know what to do here. Oh, that'll work. Why don't we try that? Oh, that's a good idea. Okay, cool. So what we're going to do is we're going to take our... I mean, it adds, you know, a bunch of annoying things to our whole build, but this will probably work. So we're going to use our breadboard. Okay, and then we're going to, instead of doing this, we're going to get, because we just need to get this to work reliably. Like, I don't even care. I just need it to work. Okay, so signal is now, okay, so now we've totally decoupled the power for the servo. Okay, so now GRB... Wait, what the hell? Why is it spazzing? It's like spazzing. Okay. Nope, it's just spazzing, dude. What the hell? I don't know what the hell it's doing. Oh, there we go. Okay, so I don't know. It spazzes until I give it a thing. Nope, it just spazzes. I think it, oh, you know what? I think it's probably, you know what? It's spazzing. It's because the pulse width is probably wrong. All right, but okay. At least we have gotten it to work. So I feel like I made enough progress on this to wait for the new servos, because I'm not going to debug it with this. So now we can hop onto CAD, grab CAD, the MG90s or whatever they're called, and we can start to make some progress on that. Because this is almost certainly that the pulse width is wrong. So it's just a config thing. Cool. All right. So, I mean, that's not the best. It kind of sucks, actually, because, I don't know. When we get the other ones, maybe we'll try it, but I just don't see this working without a breadboard. Or, I mean, without a... without a second wall wart. But the goal is to make this thing work. It's not to make it the best thing ever. Cool. Oh wait, this is not even the right thing. Okay. Cool, we can put all this away now. Okay. Fan-freaking-tastic. It's actually a total pain in the butt, but everything is always harder than you think it's gonna be. Okay, so we're 2 hours and 30 minutes into this. It's time to close all of this and hop into CAD. Oops. I'm gonna go on a walk for a little bit. All right. Yeah, I mean, look how big this thing is compared to. Well, let's grab the CAD, and then we'll hop in. Let's see how many views this has. Oh, why is there 2 people in here? What are you guys doing? Anyways, so yeah, so our next step is we're gonna take this and we're gonna replace it with the MG90S or something. Yeah, we're gonna replace it with this. What the heck? So this is much smaller, and well, I guess actually, let me think about this. Given that we're going to be using external power anyways, we might as well just use that servo. I didn't really think about that until this very second, because basically the Arduino cannot power the servo on its own. Even if you give it an external power supply, it tries to default to using the USB 5 volts, but the USB 5 volts caps out at 150 milliamps. So basically, it's kind of tricky, you know, because we need to be able to send G code to the thing. All right, I'll be back in a sec. I recently made my own bagels. Mm. Oh, wait. Oh, wait. Let's see how it's organized. I don't even know. Let's do what we did with the other one. Mm. That's a fail. What do we do? What file? I guess that's a step file. Yeah. Oh, nice. But this is all. Yeah. So my normal algorithm for all of this is yeah, it looks good. Unfortunately, the appearance didn't work, but we take this out. Or actually, wait. Hold on. Everything but that. We do this, group it, then we do an in-place thing. I don't know how we're gonna do this. Oh, I think I know how to do this. The thing is, I hate that it's all black. Can we recolor it? It's impossible to see anything. There we go. So we want to mate, not that. To that Revolut. Um, okay. And then we want to do this, fix. Okay. Cool, now we'll be able to import it. I'm going to go make the other bagel. Unfortunately, we're down to our last good one. Well, there's a couple more, but I need to add salt to it. Okay, so we did that. Okay. I feel like the 2 must be me. Makes no sense. Okay. So now we can leave this and go back to tinycnc. All right, let's lock in. I ate, and now it's time to eat with the mind. All right, so we're just going to delete this component, delete this part. Should we just start over? We don't need to start over. But we do want to... Okay, let's just start with some basic stuff. Take this part and delete it. Take this part and this part. Delete it. Okay, we have these holes here, but we want to get rid of those holes too. So we want to go here, switch to. I'm going to take this, and we actually want to delete that. Can we delete it? Does it delete the, yeah, see, that's the problem. What is this? What? What is this? Wait, let's just delete these. And delete this. Delete this. And, oh, I see. Okay, but that sketch is important. And then that's important. And then what is this? That's important. Okay, cool. So we're back to where we're at. Okay. So basically we're going to start with, we're going to define a couple of dimensions. Okay. Wait, actually, you know what? I kind of do want to assemble this thing. And just see if it works. Because if it works, we have a way to power these big servos. So it's like, maybe I'll just try that. All right, so we're going to go put the threaded inserts in here. Okay, let's just do it. And then we're going to use a normal servo hooked up to a power supply. And my guess is that we'll... okay, so then we'll still need to mess with the configuration today, which is kind of annoying, but seems doable. And then we'll modify the CAD if it doesn't work. All right. I also brought my bag of shame, which I'm going to dump out, and we're going to sort it. Clearly M3 nuts. Bunch of M3 nuts. We can do the majority of this work right now, actually. What is that? Is it a little rock? I don't know if these are M3 or M4, actually. A servo screw, some JST connectors. Okay, whatever. Alright. Let's just get the servo in. I'm only even going to do one of these things. Alright. So... Okay, need my Allens. What the hell? There we go. This is too big, and I'm obviously missing the one that I need. I knew it, dude. Where did it go? Wait, did I? Ugh, okay, fine. I gotta go searching now. Ay, ay, ay. Close enough. Close enough. Alright, let's just get this thing in here. Need another M3 by 8. Okay. I'm going to take this off and realign it. So it needs to be like... I want it to go like this. So this needs to be at 0 for this. Okay, so just do that. Yep. Wait, is it like that, or is it like... Let's see, let's put the, oh, you got it the wrong way. Where is the little thing? Here's the pen holder. Let's take the pen out of this thing. Oh, wait. This actually... Oh, that works. That might work, actually. We might be able to get this thing done today without any new parts. Fucking what? There we go. Okay, I gotta go find them. Okay, good stuff. All right, we're gonna make some progress. I'm sick of like getting heated over nonsense. Oh, okay, wait, hold on. We have an issue though. We have a design flaw. Whatever. If we have two of them, it should. No, I don't think it will. So we need to raise it up a little bit. This one's okay. I never do standard content. I never do the what's it called? Nuts and bolts and Onshape. I used to do nuts and bolts all the time in Fusion. Okay, well, in any case, let's get an M3 by 8. Did I space this wrong? What? Oh, no. No. Yeah, I was like, there's no way that's true. And yet they do seem kind of spaced weirdly. Okay. So this is what it looks like. Wow, that's real weak without... Whatever. It should be fine. It should be fine. So now our next step to do is we're just going to do a basic test. Okay, we're just going to do a basic test of, so it's going to be this 2.4 volt, or this 2.4 amp, 5 volt thing. And we're just going to hook that up directly to the power. Then we're going to get the Arduino back out. Okay, we got a plan, man. We got a freaking plan. I'm excited. We just need to make it to 45 degrees. Okay. Okay. So this is going to be held like this. Okay, where did the Arduinos go? Okay, here's this Arduino. The other one, I don't know. Okay, so let's just plug this in. And then we just need a normal cable. It takes this to pin 9. Okay, and then all we want to do is come up with something that lets me, so let's open up Arduino again. Let's just try to run sweep. Let's just start with sweep. Okay, so I don't know if this is in frame or not. Open, examples, servo, sweep. Oh wait, we haven't powered this thing though. COM7. Power it. Upload it. Well, that doesn't make any sense. Pin 9. Pin 9. So that's right. That's right. Why isn't the servo working? Jesus, there's birds right on top of me. Oh, God. The birds. Wait, why isn't the servo working? We just had this right. Wait, what is even going on right now? I mean, it seems like it doesn't have power, but I don't know why it wouldn't have power. Okay, what if we do this? Where did I put those other ones? I mean, it's working, though. That's good. So now we just need to figure out why the hell this is not giving it power, then. Let's try it on the breadboard. I don't know why adding indirection would change anything, but we're just going to do it. Maybe the contacts weren't long enough. Could be, maybe. Okay. Black to black, white to red. Plug it in. And nothing. Maybe these contacts are bad. Did I somehow bust that power? That would be awfully weird. Okay, I'm gonna go get a voltmeter then and test it. Because this makes no sense at all. These projects get so annoying, dude. It's like, what is going on here? All right. It's measuring 5 volts, so I literally have no idea. Let me try to re-upload it. But wait, didn't I do that a million times? What? What is happening? What the hell? Okay, I got 5.6 volts right here. Measuring. I got that going straight to the servo. But yet, could it be too high? Could it be too high? I don't think so. I honestly don't think so. Blood, I am crashing out. What? It's gotta be something so obvious. This is the setup. Okay, we have this power supply. It says 5.4, but it's actually 5.6. Oh, you know what it is? It's dude, I keep forgetting this. I keep forgetting this. You have to ground. You have to ground everything. It's always the grounding thing. This is gonna work right when I plug this in. Yeah. Okay, I'm so stupid. Okay, so let's moment of truth this thing. All right, sick. All right, so we're done. Oh, dude, we're gonna be able to set this thing up today. I want this thing done so bad. I want to go buy all my biology shit. I want to buy all my biology shit so bad. I got a cart that we're gonna walk through, and I'm gonna say, hey, how to set up a biology lab for $200. Okay, so let's do this thing. We are gonna be drawing images by the end of today. I swear. Otherwise, I'm freaking out. Okay. So we're gonna have to do a lot of work to get it all set up, but this is so doable. Okay, so where is the okay, so we can unplug this. Just stop it. We can unplug this because we don't need this. Yeah. Okay. So this Arduino's done. Where is the other guy? Okay, so we have this. All right. And this, let's just do this for right now, is the CNC shield. And all we want to do is we are going to keep all of this, but now we're going to need to keep the grounds the same. So we're going to do one of these guys. So we're going to go ground to ground. Okay. So now, and then we need to replace this with a male to female. I don't know if we have a male to female, so just take one. So now we're going to, what was it, Z plus? I forget if it was Z plus or Z minus. And we're going to send that to the servo. Okay, great. Now we're going to set this all the way back down here. Okay. So now we have this, and now we want to see if we can lift the pen holder up, right? If we can lift the pen holder up. So we need to go to, we need to reopen examples, GRBL servo, GRBL upload. Then we're going to upload it. Shoot. Wait, what? Damn, I need to log this stuff better. Oh, wait, no. Hell yeah. Okay. Wait, now it's not working. What the hell? It worked for 1 second. Wait, I think it's because I need to do this. No, what? Oh, come on. We're so close. We're so close. Let's reset everything. Oh, wait. Oh, wait, it's not 255 though, right? Damn it. We did the M3S0, right? Why doesn't it keep scrolling down? Why aren't we... Why isn't it working? Why aren't you looking? Okay, but now we switch. Okay, so what we're going to do is we're going to switch back. Boom. Boom. Right, we can leave that. But then this goes to... I heard it work too. That was the worst part. So, alright, so whatever. Pin 9. And then ground. We just need a ground pin. And it's working. Maybe we do want to get out a oscilloscope. Ooh, that's no good. Okay, wait, hold on. Let's make this. This is bullshit. Fuck. Still going too far. Maybe like. Fuck. I feel like it's not changing at all. I feel like it's doing. Oh wait, no. You know what? Because I'm stupid. Can you see that? I still think a spring would be good, but it does seem like pretty reliable. All right. It's good enough for me. For right now. We'll redesign if it ends up becoming an issue. But now we gotta figure out why the hell the GRBL shit is not working. Why, bro? Why is it not working? Okay, wait, why don't we do a test? Wait, no, wait. Will this test work? We need to know what pin Z plus is connected to. How do we know what pin Z plus is connected to? I think it's gonna be 9. So we're gonna try to do this script uploaded to the other board. So if we quickly look at this, 9 is, we wanted it Z minus. Okay, we're gonna try. We're gonna try 11. So we're gonna change this to 11. I'm gonna swap these out. We should be able to just do this. Oh yeah. Sweet. Okay. All right. I mean, it's exciting for me, but it's not really indicative of anything. What we need to do is we need to upload that. We need to go to. Okay, but this is the wrong directory. We need to open up Documents, Arduino, Libraries, GRBL Servo. And then we need to modify this. And you know what I'm going to do, actually? I'm going to just do git init. Okay, just so we can track the changes. Config. I'm guessing that, there's a bunch of settings related to servo. Is that what it's called? MG995? Yeah. CPU map.h. Why is it 38? Wait, where does it say digital pin 11? Oh, there you go. Cool. So wait, so let's Oh! Oh, I don't know what I changed, but it's working. What did I change? It's working, bud. It's freaking working, bud. So let's try to go back to 0. Okay, that's 0. Yeah, so we need to go to 180. Or wait, no, we need to go to 220, 255. No? Okay, so I think something is wrong because let's go to 0. Wait, and then it just stops working. Or it's not moving enough. Oh, wait. Okay, so M3S255 doesn't move. M3S0. Oh. Freaking locked, man. Let's try that. 32 for max and 16. Okay. Did I do M3S0? Wait, what? It's like kind of flaky. It's kind of flaky, man. It's kind of weird. Like there's a delay in between when it does it. What I'm gonna do? Well, what's the baud rate? 61. Because typically on sweep, where do I see the baud rate? I think it's. Wait, what? Wait. Something is wrong. Let's see. Why is that? Oh wait, let me see if I get this right. Wait, hold on. Oh wait, I think I understand my confusion. The frequency of the carrier signal of the pulse width is not changing. It's when you say like whatever the minimum to maximum range, that's the amount that it's on, right? Maybe it would be fun to get a oscilloscope and debug this. Let's do it. That sounds fun, actually. Let me get some water, though. Okay, so here's an oscilloscope that will work with my computer. This thing is so cool, man. I love this thing. It's just always a matter of finding space. Okay. Laptop. All right. Okay, we're gonna have to change the wiring around a little bit, and then we're gonna have to open up waveforms. So let's just get okay, wait, hold on. Here's what I want to do. I'm gonna do new sketch. Then I'm gonna take this. Rewrite this script so that it reads from serial input, and I can just give it a degree, and it'll write that degree to the servo. Okay, so we're gonna now plug this in to like here, and then this one into ground. Okay. Now this is going to go to, oh wait, this is Z minus. Let's unplug this. Then this goes to here. Okay, and then, oh, and we need to change this to pin 11. They're both on pin 11. That'll remind me. There's always something there to remind me. Dun, dun, bum, 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 bum. All right. Okay. So now what we've done is we've broken out the output of this Arduino, which you probably can't see. This Arduino now goes to the breadboard, which is being sampled by the oscilloscope, as well as being sent to the thingy-mabob. So now we can open up this thing, scope. I don't know. Is this just gonna work? I think. Wait. Oh yeah, so it's at 0 right now. So now we're gonna do this. This channel 2 or channel 1? Let's turn off channel 2. And then let's go to ChatGPT. Write this. See, wait, but did we even have that in here? Yeah, that's what's confusing to me. It's like, Oh, because cereal. Oh. Okay. There's always something there to remind me. All right. What? Why did it move back though? Or did I accidentally do that? No, what? Why? What? What? Why does it move back? Let's just close. Oh, let's just close this. I feel like this may be doing something stupid. What the fuck? Wait, hold on. Not this one, this. Dude, this thing... Okay, I don't know. I don't get it. When I run this script and then I start giving it values, I give it a value and then it returns back to 0. I don't know why it does that. Okay. Nice, nice, nice. Servos and Arduino is just such an annoying thing to work with, man. All right. Nice. Okay, so it's at 150. We put the thing on here. Wait, no, wait. That's not even what we're testing. Okay, what we're testing is... There's always something there to remind me. How do we get the... I forgot how to do this thing. We need this thing to be edge, level, like 2 volts. There we go. There we go. All right, so we're going to write a 0 to this thing. Okay, so we wrote a 0 to it. And now what we want to know is we want to pause it. And we want to draw from like here. Oh, okay, wait. Okay, so the... Wait, why is this changing? Oh, that's weird. Okay. This script is working well, and this is what a 0 angle looks like on the oscilloscope. Help me understand the results and debug why the GRBL is not doing what I want. There's always something there to remind me. Bum, 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 bum. Okay, wait, hold on. Let's test that out, right? Okay, so so the frequency is the wrong. The frequency is wrong. Okay. Okay, so it seems like it's mainly that GRBL is using an incorrect frequency. Tell me if that's right. It's always all around. Okay, so what we're going to do is now we're going to look at the pulse width measurements of. So we took the appropriate screenshots, and now all we need to do is send this guy. So we're going to unplug this. Okay, we're going to unplug this. That can stay grounded, but I would prefer it to be way over here out of the way. And then this is pin 11, so this is going to go here to the servo. Great. Unplug this just for whatever. Okay, so we are back to where we were. Okay, and now we want to run this. And we want to close this, file, examples, GRBL servo, GRBL upload. And then I actually do want to change this back to its defaults. So let's just do a git stash. So then if we go to this, we have that. It's so weird. It's like, yeah. 38. Pulse width modulation range. Register. Right, so I think that this we need to change that, I think. Okay, so we didn't upload it though, right? So we need to upload it. Okay, then we need to change the baud rate back to this. See if that's right. Okay, we're getting everything. So now we need to do M3S0. This whole thing is a 0. But that's not right. It's not moving the Does it give me a frequency when I'm just running this? Yeah, see, this is going way too fast. Somehow the scaling is wrong. Right? Okay, wait, hold on. So let's do this. Let's go back to play. Okay, then we're gonna write M3S0. Okay. All right. Okay, so M3S0 gives a totally flat signal in. So I've gone back to using GRBL and the shield. M3S gives totally flat signal. The original GRBL servo code and the shield. M3S gives a totally flat signal in scope. M3S255 does give M3S255 gives a all high. Now M3S128. Oh, it did move it. Wait, did it say that 50 hertz? Wait, where did it say pulse width? Oh, delta X? 1 over delta X, though. But then where is... what? Let's try this. Can I do a print? Oh wait, that's not gonna work. Oh, for real? Let's see. I'm skeptical, to say the least. Wait, let's go back to 128. Wait, it didn't change at all. Wait, what okay, wait, let's just mess around a little bit. Default disabled, uncomment to enable. I'm pretty sure we need to leave this thing. It moved. What if we... I don't know, something is wrong. I don't know what this means. Ugh. So, okay, wait, hold on. Basically what I want to know is, what is this? What does that mean? Okay. The timer counter control register B of the microcontroller. Right. Yeah. Timer clock frequency. Wait. TCC R2B is a hardware register in the chip that controls the clock, source, and pre-scaling for timer 2. Timer 2 is responsible for generating the pulse width modulation signal when controlling the spindle or servo. Okay, those are clock select bits for timer 2. Together they determine the prescaler, which divides the microcontroller's clock frequency to slow it down for timer 2. I don't understand how do we get 1024 from... Oh, that's the max value? Okay, so this is just a table. It's in the data sheet. Okay. You get 3 clock select bits. 2 to the 8 is or 2 to the 7 is... Okay, so what I don't understand is earlier we saw that even when I had the 1024 prescaler, we saw like I think it was like a 1 kilohertz signal, not 61 kilohertz from the oscilloscope image. let's go back and verify that. So this is see, delta X is 1 millisecond. But that should be 60 milliseconds. Oh, wait, no, wait, hold on. Should be 1 divided by 60. Yeah, I'm pretty sure that's right. This is too advanced for me. What the heck? This is some real embedded programming. This is like more advanced than I'm used to. Where are the changes in this thing? Oh. Silly. Okay. But I can't get this thing to actually do anything. Spindle is servo. We have that, right? Default disabled, uncomment to enable, but it is uncommented. Okay, so I'm tweaking out, bro. Why is the pulse width so fast? It's supposed to be way faster. I mean, slower. When we go like this. We're getting a 1 kilohertz frequency. I honestly don't even know how that's... It's running, right? Oh, wait. It's not doing anything. Oh, I don't know if... It's so unreliable. Or it's so laggy. I don't understand why it's so laggy. It's got to be the frequency. I think if we sort out this prescaler thing, then it'll work. But it's like... Okay, what is it at right now? M3S1? What does it look like? Okay, so it's thin. I mean, at least like the pulse width is doing something somewhat sensical. Broski, why isn't it doing what I want? I think probably what I want to do is strip out a bunch of this and just get the signals right. Just get the timers and signals right and like not use the shield or anything. Because the shield is just a breakout board. It's not like it's got a whole lot of electronics on it. For instance, the Z minus N stop is literally a pass-through. So technically we could just... Okay, so yeah. So just to get rid of all these wires, we're going to do this, we're going to do this, we're going to do this. We're going to get rid of this board just to clean up the table a little bit because I am freaking... Oh, and this thing is getting hot, man. What the heck? This thing getting real hot, bro. So if we just do this and write 0. See, that's the weird thing. Also, that's so weird about this. I don't understand why this is the case. But so this is 0. But when we wrote 1, 2... When we wrote 1 to the GRBL code, it went further than this. So I'm not getting... Okay, so hold on. First off, I just want to say... Okay, let's try this. It's going even less far. Okay, so I'm gonna close this. I'm gonna make this. That's so weird. Pin, min, max. Dang, bro. I don't know. Ugh. I don't know. I honestly have no idea. I have no idea how. I mean, this. Why don't we just try the other one? We could just try this one. Use pin D11 to drive the servo. Use the commands, whatever, between 255 to rotate between. Okay. Command MO5 to turn the servo to 0 degrees. You can change the pulse duration in the file spindle control. Yeah, short, long, invert. I might just try this code. This code seems pretty simple. I don't know what's different about it, but let's do it. Alright. Alright, it's time. We are going to download this, and we are going to, we need to rename it though. Oh, this is literally just a flat. Okay, so what we want to do. Okay. We're gonna try this. We're gonna try this again. All right. Let's see. So we're gonna upload. So we need to what? Save as. This is servo serial. God, it's getting cold, man. Why does this keep showing up? Okay, whatever. I don't care. God, Arduino is so annoying. For real. And you can't cancel this stuff. It's just so ridiculous. Okay. Wait, where can I change the baud? What's going on? There we go. Okay. Fuck. Why? What does it say to do? I probably have to... Okay, let's... Okay, this is the other one. Open with... Is there an open with? What does he say to do? spindle control.c. What if I try to unlock it? Oh, there we go. Wait, but the no, the power's plugged in. All right, let's look at the oscilloscope, I guess. It's running. Still at 1,000 hertz. Let's do this. It's wider. It's not doing half. It's not controlling this fucking thing. I'm so pissed off, bro. I'm so pissed. That's click upload. That's it. Oh, man. Wait, so I actually, and then I messed this up too, because this, I actually want to undo all of those changes. I should have made a version, bro. Can I undo? Oh, no. Dude, that's no good, man. Oh, boy. Ah. Why did I do that? Why did I do that? Oh, come on, man. You can't undo after you did it? Oh, jeez. That's not cool. So that means we gotta redesign those two parts. Let's open up the other gear. This is the not one. And I don't know, it didn't do anything. Maybe, I don't know. Let's close the serial monitor. Open the other one. I swear, if I ever see that file again, I'm so ready to be done with Arduino, to be fully honest. But nobody's written GRBL for MicroPython. No. I don't know. What happened? Did I change something in this thing? That's the only change. So let's compile it again. I don't remember having to unlock it, by the way. I think it might be doing something weird. Watch, when I open Arduino, I swear to God, it's definitely going to be servocontroller.i now. It's just so stupid. Oh my God, it's just so stupid. I've got to be missing something so obvious. And of course, this thing. Can I just edit this to be fucking nothing? Whatever. That's actually kind of spooky, right? Because, wait, oh, no way. Oh my gosh, wait, is that actually what's going on? Or is it, wait, hold on. Let's just rename this. Okay, let's rename this and try to recompile it. I think that might be something. Can I give it the actual path? Because what I want to give it is this. Okay, wait. If we open up this one. Wait, oh, did I click the wrong one? Oh, I clicked the wrong one. Examples. Oh, I clicked the wrong one. Silly me. Yeah, see, okay, all right, okay. Wait, no, but that was 0, so that doesn't mean anything. So if I hover over this, okay, so never mind. Okay, all right, that would have been weird. Holy crap, okay. All right, let's just move these out. Fucking God, dude. What is still open? I don't even know. I'm getting so... Actually, can I do this? Will this work? Of course, it forgets everything, too. That's... They were the first ones to do it, and they did it the worst, you know? And it's... Why is it doing this one? How is that even... Wait. Oh, because I'm a dumbass. Okay, wait, hold on. Bruh. This is really getting to me. Please tell me it remembers my thing instead of just clearing them out. Of course not. Of course not. Of course not. Of course not. Stuff is so stupid. Come on. I just really want to make this stupid thing move. I want to make it move. What? What happened? What even happened? All right, I'm just gonna I'm gonna do this. I'm gonna delete this whole folder. Oh. I don't know what happened, but I'm just going to let's keep a terminal open. And then we need to go to this. It's this, but it's but how do we get the URL to this thing? There we go. Oh, this doesn't work. Are you kidding me? Okay, we're recloning it. Okay, now we're going to explore GRBL servo. Okay, then we're going to take this. We're going to rename it to well, we're going to keep it as that. We're going to just keep it as that. We're not going to change anything. The old one, we're done with the old one. Documents, Arduino, libraries. We're going to paste this in here. We're going to delete this. Then we are going to go here, GRBL upload, GRBL. Okay. I think this better work. I think this better work. I think this better work. It's a funny thing to say. Okay, good. What? Damn it. All right, so it moves. I don't know, probably couldn't hear that. It does move. But oh, so it is doing 60 hertz. Oh my gosh. It must have been looking at the wrong file the whole time. I don't know what happened. I don't know why it was at 1 kilohertz. But okay, so it's looking good, but it's not moving how it should. Wait, actually. No, yeah, it's not moving far enough. I don't know why it's not moving. It needs a bigger pulse width. What's the pulse width here? So the frequency is not 20 milliseconds. So we need this to be, so that's like closer to 1. So what we want to do is we want to make it like, okay, I think I'm at a point, bro, I can see it. I can see it. It's happening. It's all happening. This is one of the funniest things ever. It's like show more options and it takes forever and then you get all your stuff. It's funny. World's so funny. And then we want to do this. Okay. So then we want to go to this, is it CPU map where those numbers, those special numbers, let's see. Okay, so we don't want the prescale because this is perfect. This is perfect. This is doing exactly what we want. What we want is these max values. 2. So it's saying 2.5. I think that that's wrong. We're just going to try to recompile it and see if that increases it. Because right now we're seeing, wait, that's at 255, right? Let's run M3S255. Let's do M3S0 and see what do we, but it's still not moving nearly enough. Okay, wait, let's run it. It should be, okay, so the min, that is right. That's about half a millisecond. But so we're just not getting enough. So let's just upload this and see if we do 255 now. I don't know what this number actually does. I don't know where we can, this is right though, but this is wrong. I don't know why it's wrong, but it is. And then for some reason we have to do, this doesn't work until we do $X. Okay, it's farther, but it's not far enough. Let's see. I think, so let's make it like, I don't know, 128. Let's make it 255. Let's just mess around, right? We're getting there. Ooh. Oh, we're getting there. Ay, 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 bro. We're so close. Wait. But what did I set the max to? Wait. Oh, wait. But what is the pulse width? The pulse width is longer, but it didn't move. That's too long. Maybe it's too long. What if we do 200? No. 150? 128? Oops. Damn it. Is it because the frequency is too fast? I don't even get it. Wait, what if we try 254? Is that going to change it? I feel like no way. But let's go back to what it was. So we're at 128. Or we are at 64, right? Wait, I don't remember. Let's run it again. Oh! We got it. Oh, yeah. So we're going to go to 200, and then we're going to go to, like, 100. $200, 100. 200, 100. Okay. We did it. We did it. No big deal or anything, but we freaking did it. All right, so here's a little demo with webcam on. Okay, so we have this Arduino, which is running GRBL, but it's modified so that it changes its timings or what have you. And then if we do this, where we send a M3 S200 to it, or 100 to it, it raises the pen too much. Okay, so 200, and then let's make it 150. Because it really doesn't need to raise it all that much at all. So then you go 200, 150. 200, 150. 200, 150. I could do this all day, buddy. I could do this all day. Heck yeah. Oh, man, that was annoying. I need a shave. Look at my freaking fuzz. Dude, this year, it actually, Ole would know. It got real nasty. All right, I feel good now. I don't know what I did, but I feel good. Okay, so what's next? Now that we have, we got to redesign those parts that I lost. I guess this is why you got a version. I should have made a version. Damn it. I should have made a version. Okay, well, we can pack all this stuff up, right? Okay, so here's the plan. So let's get the webcam out. We're going to get, where's my big bolts? Did I never bring those big bolts? Oh, I never got the big bolts, I guess. I got the springs, but not the bolts. Okay. I guess so. Oh, wait, yeah, I did. Yeah, I did. Okay, so what I was thinking for the design, I drew this probably like 5 hours ago. Alright, so we can disassemble this stuff. Alright. I don't know what it was, but the pre-scaler, or whatever it was, needed just a little bit of tweaking. The oscilloscope actually came in handy, man. The oscilloscope came in handy. Pretty cool, actually. Okay, so we have these pretty... oh, wait, we have these, too. What are these? These are M4 by 30. This is going to be perfect, I think. Dude, buy yourself some bolts. That's just a good thing to do. And then where are the M4 washers and the M4 nuts? Oh, and this is so sweet because I got a huge pack of... At the time, I thought I was splurging, and honestly, I haven't used the kit that much, but it's great to have these backups. And I have, like, M2 all the way to M8, right? So I got a pretty wide range of, I guess I don't have M7. I guess nobody uses M7. All right, we just need one nut. And here's the idea. And I like this kit a lot. I don't know why I like it, but I like it. Even though the downside to this kit was that it's not socket head. I would prefer it to be socket head. I don't really like the hex head because then you can't tighten it as easily. But it's fine. So let me get a spring out. Okay. So these are pretty big, but we have skinny ones, I thought. See, this is kind of perfect, right? There's a spring on here. It pushes on Okay, so let's design this. So let me get my calipers out. All right, we're almost done with today, man. We're almost done. Like 17. But we want it, let me think about it. We want, we might need 2. And then, okay, this is going to take some serious thought. Like, I've never used springs before. I've never had to do something where you have to preload some tension onto something. So it's going to be kind of an interesting thing. Okay, we have M4 by 20s too, which is... So we got to think about, because if there's a bolt on one side, if there's a nut on the other side, then the distance between the... And I guess you want the nut on the bottom and the bolt on the top. Why is that? I don't know, maybe it's the same. You kind of want it to have Loctite on it, because it's not going to be at the bottom. It's not going to be tightened by anything. So it could just like roll down it over friction and time. So maybe... Let me look at this. Okay, hold on. So we don't need the springs really yet, or we'll just put them to the side. But what I want to think about is, okay, so this is going to be like this, and then the spring and bolt are going to be like this, kind of, or like this maybe. So that means that this is pushing down, and then the servo is going to push against it to compress it more. So that means that we... So this is 30. This is too long. So what we're going to do is we're going to define as a driving dimension basically the initial compression amount of the spring. And that will define the preload. And I think that, I mean, not like we're going to do spring measurement, but I'm pretty sure that if you... I'm pretty sure that the like common mechanical assumption with springs is that they're all linear, and so that the force pushing outwards on the compressed spring is equal to some proportion, some constant times the amount that you're pressing, the distance that you've pressed in. I don't know if that's true, but let's just get designing. We can unplug all of this. This is cool. This is a fun project for sure. So let's just get this out of the way. This out of the way. We don't need the oscilloscope anymore. The Aussie. Okay, so we're just gonna hop into cat. So, all right, this is a pretty easy part, I think. The only thing is we're gonna have to redesign some stuff. really quickly. Four. 14, so that's 10. And 8. Oh, really? 8? Okay, well. Alright, so we're just going to make it a new part because I don't have the patience for this. So, wait, damn it, I forgot already. It's 8 by 14. And then the depth, it's probably 3. The cleanup today is going to suck. That's the problem with, but I got to do it outside, you know, that's just how I am. What? And then how tall is this thing? And then I'm assuming they're both centered, right? Actually, I don't think it is centered. Oh, come on, bro. Right, because what is it that we need to measure? So now we got to open up the freaking... what is it? It's going to be from this face to this center. Min dist is 3 and the radius. So you can infer the radius from to center dist is 5. Okay, so then this is a radius 3 hole. Is that true? No, radius 2. Wait, it's 1 plus... Wait, because this is... Wait, what? The min dist is 3. Okay. Wait, what? The radius is 2. The diameter is 4. Okay. So then it's 2 plus 3. Okay. So it's 5. So the center of the hole needs to be 5 up. Okay. 5 up from the top of this thing. But how tall did we actually make it? So it's let's just make it 6. Oh wait. Is that right? That doesn't seem quite right, but okay. Can I get the center? Oh, but it's not the center. It is like this, and then this is going to be 4. 4? No, it's 4.7. And then the distance between here, I should have done it on the other side, right? Yeah, I should have done it on the other side. I'm so stupid. So let's just undo this. so this to here needs to be 3. This to here needs to be 3. Is that true? Is that really what happened? No, it's not. Oh, wait. What? Fuck it, let's just take one out. It's 2.5. But from the bottom, oh wait, but this is actually no, so we don't want to do that. We want to do, this is, wait, 5.35? I'm pretty sure it's just this. Right, because the distance between this and there has a center distance of 5. Okay, I think that's right. Okay, so that's the part. Now we just need to do this. It does look a little bit different, though. I don't know, maybe it's the same. And then what do we do here? This is just center, right? Is it center? Yeah, it'll be fine. If it doesn't work out, I can curse myself later. So this needs to be 3.4. Oops. Okay. Redoing stuff I already did. This used to be so fun doing CAD, but CAD actually stinks. CAD is actually boring as hell. Okay, so we need to go back to this part. And then we just need to calculate where the hole is. We're going to just add the holes. Because I like the positioning of it. I actually think it's good. So we're going to take this sketch. Okay, then from here, it's going to be 4 plus half of whatever that is. So wait, can we open up pen holder? Where is that part? Okay, so I'm going to take this center, this, and the center, but we don't want that center disc. We want the Y. It's 9. Okay, so we're going to make from the center, we're going to make 9 to the center. So what we're going to do is we're going to do, is that the center point? Is it? Okay, I guess it is. So that means that okay. This is going to be 5 minus 0.3. And same here. So all we need for this part is this extrude move 4. Okay. All right, great. So now we can assemble this thing, right? So what we're going to do is we're going to insert 2 of these guys. Okay. Move this. We're going to mount this onto there. Rotate it like that. Then mount. Oops, not that. This onto there. Rotate it. Okay, then we're going to insert the. Is it that? No, it's not that. It's not that. Cancel. It's that, right? Yeah. And let's see, how does this go? This is going to go like that. So then that means that this bottom one gets mounted to this part. All right, great. All seems good. This is kind of an oversight, but I just cannot be bothered with it right now. So, okay, so the next step is we're going to add, I guess the question too is how are we going to, so let's add this back. Now we can reassemble this thing now that we've gotten back to where we were. We're getting there. Okay, so the first thing that I want to do is I want to make this thing extrude up to here. So we're going to go and we're going to modify this. This needs to be 4 mils less. So we're just going to go switch to, and then when we click on this extrude, okay. Okay. That doesn't really help because so a question is basically how long from the center is this thing? Let's round up and say 20. So if we were to go to this part and look at sketch 8, So wait, so this is a point, right? This is a rectangle. The point. This is the width of the. This is the paddle, but the paddle is actually like 20. Oops, not 30, but 20. Is that true? No, it goes to about halfway. So let's undo that. It does go to about halfway. So we should have. So what I'm thinking is, I don't know. This is my first time doing anything with springs, so I'm kind of in the dark here, but what I'm thinking here is pen holder, open in new browser tab. Damn it. Okay, so wait, let's just draw a construction line right here. So we can't go. Alright, so what we want to do, maybe like right here. This is kind of a total guess. So this is going to be 5.4. Wait. Where's our spring? This is 5.5. So we're going to make this tight. Unfortunately, we're going to make this 5.1. This might not fit. Depending on how it gets printed, maybe 5.2. We'd also put a bigger spring on it. I feel like that's kind of the perfect spring though. Okay, 5.2. As long as it doesn't fall through the thing. So we want this to be, so let's see, what's the distance between here and here? It's 10, so then let's just make, oops. Let's make this 5, and then let's make this, let's see, what is this width? From here to here. It's like a random number, what? $24.6. Oh yeah, right, because of the clearance. Okay, so whatever, let's make this 7.5. Okay. Okay. So what's going to happen is, okay, so let's just start designing then. This next part is going to be pretty easy, and then it's just going to be hard to align the, so Y holder right is where we need to be. Okay, so what we're going to do, sketch on here. I'm going to draw, I guess we're going to draw 4 circles. Let's draw half and mirror and then merge. I don't know. I never know what's better there. Whether or not to do the anyways. So what is the hole gonna be? Because we're definitely gonna it's gonna be like we always do. Yeah, 5 minus 0.3. And then okay, so we're not gonna draw them over there, we're gonna mirror this thing. Alright, let's just make This seems good. And the distance from here to here, 7.5, that sounds good. Great, now we need to take these, extrude, remove, 4. Okay. Without threaded inserts, like how would I even make this part onto here? Okay. So what do we want to do now? We now want to draw another sketch on here. That's gonna be like this. Okay, let's make that 20. Or wait, yeah, let's make that 20. And let's make that 10. Or let's make it a 15. Is that too big? No, I don't think so. I think that's fine. Okay, and we're gonna take this. We're gonna extrude. Well, actually, we're gonna take also this. I'm gonna extrude this as a new part by 3 mils. Okay, but then we are going to sketch on here, hide the part, click on these, use it. Oops, click on these, use them, re-enable this, take this. This is going to be 3.4. Okay. Oh, yeah. Okay. Oh, wait, did it do it? Oh, it did it. Okay, good. So, so there's that. So we can sketch on here. So so now we need to know how tall this needs to be. So it needs to go at a maximum, the maximum amount. Okay, so the spring len. So what was this? 17, and then this is 5.4. Okay, so we so from here to here is 20. So 20 minus 3. 20 minus 3. If I raise this thing off that plate by 20 minus 3, these will be level, pretty much. We'll take that specific number. It's just like oddly specific, honestly. I don't even really get how that's... Oh, is that because there's a little gap in there? A little gappy poo? Yeah, so we don't want that. So I'm almost positive it's 20. So we are going to take it 20. It's going to be 20 minus 3, 17 plus 17, or 15. We want 2 mils of compression. Or let's say 3 mils of compression. 4 mils of compression? I don't know. All right, so let's just say it's going to be, wait, where were we? So it's going to be 20 minus 3 minus plus 17 minus 3. Okay. Then we're going to make a plane. Oh yeah, what you're supposed to do is you're supposed to click on these, then do plane, and then it knows it's a mid-plane. That's the smart way to do it. Then we're going to do this. Normal, oh wait. Sketch, normal, G, 3, okay, extrude, up to face, this face, there, mirror, and then features to mirror. It's going to be features, and it's going to be this extrude, this extrude, this extrude, and this extrude. And this is the mirror plane. Okay. But then what you want to do is you want to take these two and you want to merge them. Can I merge? Boolean. Okay. Great. So now let's look at what it looks like in here. It should come in, right? Mate error. Oh. Oh, good. Wait, no, wait. No, that's fine. Wait, hold on. Let's just delete it. This always causes me trouble. Oh, yeah, because I did get rid of that, huh? Wait, did I? I think we want it to be this way and this way. I should learn this at some point. Okay, then if I play it, oh, it's a slider. Okay, but then the limits are okay. What? Okay, well, it's in there. I just can't. I just don't know how to do it. Anyways, but now we want to. But we want to update all this stuff. Oh, also, this isn't even going to work, man. So we're just going to have one hole here. It's going to have. We're just going to use 3 holes. So then let's go back to this part. So we're going to design it all as one thing. So we're going to undo this. We're going to delete these 2 features. We're also going to delete this feature. Okay, so now we want to mirror. We do want to mirror. We want to mirror just feature mirror. Oh wait, no, wait. Wait, when we did this sketch, it's not that. What is this? Okay, so we're going to do mirror. It's a sketch mirror, so we need a mirror line. So let's just do this. Line, construction line. Wait, we're on the wrong thing, though. Wait, where is the inconsistent? Oh. Okay, that's fine, but we want to go back to that sketch. Which sketch was it? 9. Okay, so we want to mirror. Yeah, but we want to draw a construction line this is the thing from there to there. Okay, then we want to mirror across this line, this hole. Okay, and then when we do that extrude, this extrude, wrong extrude, this extrude, we also want to select this bad boy. Okay, and then when we're doing this sketch, we might as well also, wait, so when we do this sketch, we might also as well do a thing like this. So what is it? We made it 20. No, wait, is that 20 or is that like 15? That's 15. And then this, we can make this whatever we want. And I think we should make it like 10. Maybe 10. Let's see, do we have the space for 10? Just barely. So that's sort of where we're at. We could make that shorter, but I think we're good. So we're going to go like this, then we're going to take this extrude, and we're going to also do this. Maybe we can make this further in. Let's see. Well, no, but it's the same. Oh, wait. Wait. Sketch, we need to do this thing again. Oh, wait. Okay, cool. I mean, we really don't need 2. I don't know why I did 2. Let's just rethink that. So it's this sketch, and we're just going to delete this. And then this, that's fine, except for that. And then this extrude, that's all good. Okay, but we need this sketch, and it's going to be, how much did we say? We said 10. So I guess I could have mirrored it. Okay. Why didn't I think of that before I did all this? I think I just want to take... well, okay, wait, hold on. Alright, so we're good. So now we just need to extrude this. Oh, wait, hold on, what's wrong here? I think we can just do that. And this. What was this? What is this? Oh, this is nothing. Okay, so let's just take this and extrude it to this plane. Up to face, plane, this, mirror. Are we doing feature mirrors? I think we're doing feature mirrors again. So it's... you can mirror the plane itself. Okay, So that seems pretty good to me. It's kind of an absurd part. It's kind of an absurd part. But yeah, you gotta get it done, bruh. You gotta get it done. All right, so these holes are there. That's great. So now we can insert the part, and let's rename the part before we do anything silly. So this is going to be the spring holder, really. So rename spring holder. We're going to insert spring holder from this. Wait, oh. Why didn't it work? Okay. Nice, we got some room. Okay, hold on. Why don't we just do this? It's kind of janky, but I'm going to sketch on here. Okay, we're going to take this construction line. Wait, we got to open it up. Okay, it's right down the middle, so at least we have that. So wait, let's make a line. There we go. Alright, so we want a rectangle. It's like, let's make this 30. Do this and this, midpoint it. Okay, and let's just extrude this by 15 or something. I don't know. Okay, so now we need to figure out, though, how far off center is this thing. So if we're going to switch to this, because we have the center line, so all we have the center line, and then we have this should mate with, it doesn't exactly, so what we want to know, oh, but this does. This does. So we want to know, and then the thickness of this, so these are, that's 5. Okay. So, wait, where is this plane? This is, dude, can we hide this plane? All right. Okay. It's 4.8 off. Okay. So let's just get that sketch started. God, we're so close. We're literally so close. All right. I'm going to sketch on here. Draw that midpoint line. Okay, then we're going to draw a circle. And this circle is going to be 5.2. And its distance here is going to be 4.8. Is that right? Yeah. Okay, now we just need to know how far back to go. So the distance between that face and that face. So, okay, so let's just say click on this and click on this. That's the min distance. We don't want the min distance. We want, what is that? That's the Z. Is that right? Let's try it. Let's try it. Just go here. That doesn't seem right. I think it is. Okay, if we go normal to it, we should be able to see that it's... what? Wait, first off... Oh, well, okay. That's a little goofy. Oh, but this is going to mess with everything. Okay, hold on. But it should be that distance, right? Dude, it seems all wrong, though. Oh, no. This seems right. It just seems off by, like... Maybe I was reading the wrong measurement. No, it's definitely this. But, oh, but that's... Oh, yeah, okay, wait. It's center dist. And it's 10. It's 10. Okay, cool. So wait, so we just need to go back to here, here. So we can take this extrude and just make this like 5. And that's whatever. Okay. Oops. Okay. So are we good, man? Do we just have to print this part, this part, this part? Oh. All right, I'm going to export them and print them. We're going to see what happens. Well, it's always the worst cleaning up when it's dark, especially when you got so much stuff. Let's see, how long have we been going here? 6 hours. 6 hours, bro. The zoo.dev videos are getting kind of popular, man. This is the first time I think that I remember that something... It's mostly search, right? Yeah, they're pretty much all search. Search and external. Someone posted this thing somewhere. I don't know where, but someone posted it somewhere. Okay, we're close. Let's just export and start the print, and then I can get on with my life. Get on with it! Okay. Export. Spring holder. Okay. Wait. This thing. Okay. We need this thing. I like that there's just a ton of empty space here. Makes so much sense. I don't know why. There's so much empty. Okay, we need to export this pen holder with spring hole. Okay. And then, are these just downloading to downloads? I hope so. Okay, and then we need, not pulley wheel, but Y holder, right. Okay. Okay. Alright, so now we should be able to just do bamboo. We're getting close. This one is so simple. I love this design, dude. And what if you put little like balls under that? It would roll so nicely. Okay. So, dude, this design, I like this design a lot, man. It's like fully 3D printed. Just 2 rack and pinions. This is really well designed, man. I really like that. Okay, bro, BBL is getting an update. Oh, BBL getting an update. Okay. It's gonna ask me every time. I'm gonna do this one with supports. Oh wait, we just enabled supports on everything? No. We're gonna enable supports here, and we're gonna enable supports here. Slice it. Yeah, I think that this will be a good idea. We'll see how well this does. We'll see. I think it'll be okay. Getting this stuff out might be kind of a pain, but we need to resync. All right. That seems like a good point to end the stream. We'll try to assemble it tonight, maybe.